Okay, welcome back to the channel. Let's focus on how to draw enantiomers, and this is under what optical isomerism. So, therefore, what is enantiomers? Enantiomers, these are chiral molecules and it's what mirror image. And I say a chiral molecule is that molecule that have what a chiral center, and a chiral center is that center that have four different groups. So, what we want to understand is that a chiral molecule and its mirror image are not meant to what coincide with what each other. They rotate the plane of plane polarized light. So, but I'm not going to go into those definitions. I already have done videos on how to what identify a chiral molecule. From that chiral molecule, you need to what, get what numbers of stereoisomers, which what a chiral molecule possess. So, if you have not checked out that video, then I will advise you what check out that video. Now you see it at the description, or you see it by the end of this video to display, or you see it up here. Do that. So let's go into it. So yeah, I'll tell you that enantiomers, these are chiral molecule and it's what mirror image. So if for example you have a chiral molecule here, X, Z, Y, and what A. So a carbon atom that have four different groups called chiral, chiral what? Carbon. I get it. Another you can call it what is called center or asymmetric asymmetric center. So these are what the common name you can what call a carbon atom that is having four different groups. Now, every chiral molecule, as a matter of fact, every molecule have what mirror what image. Now, if I decide to put a mirror here, uh, let me draw the mirror image of this guy. So we have a carbon here, Z, Y, A, and what X. Now, what happened here? This is the chiral molecule. This is the chiral molecule, and this is what the mirror image. So a chiral molecule and its mirror image are called enantiomers. Are called what? Enantiomers. Do you get to see that? So these two rotate the plane of plane polarized light. Now, what you want to understand here is that they both have physical and chemical property, but they exhibit different rotation. Now, one will rotate the plane polarized light to the right, and one will rotate towards to the left. If, for example, here we have CH3, here we have CH2, CH3, here we have what? H, and here we have what? Br. Now you can see that this carbon atom have four different groups. It's okay. The name of this guy is called 2 bromo 1, 2, 3, 4 butane. This one is a chiral what molecule, and it's having how many center or chiral center? It's having one chiral center. Do you get that? So now, if you should draw the mirror image of this guy, like you place a mirror here, I want to draw the mirror image of this guy. So what happened here? We have CH3, CH2. Here we have CH3, CH2, and here we have a carbon here. Here we have what H. Here we have CH3. Here we have what B. What R. Just this that. So they are called enantiomers. So a molecule and its mirror image are called enantiomers. So in this video here, I have to teach you how to draw enantiomers. So we are not drawing enantiomers here. I'm just teaching you what is chiral center and how to identify chiral center and what enantiomers. So how do you draw enantiomers? Enantiomers, we have two main formula. First, we have what the perspective formula. Two, we have what the Newman projection formula. So I want to teach you these two formula on how to what write or draw enantiomers. So the perspective formula, perspective formula represents or draw the chiral molecule in three-dimensional form. Do that. Now when we look at what three-dimensional structure, now you find that there are some points of that structure that is pointing towards the viewer, as if they are what going to come out of the what plane of the paper towards the viewer. While you have some other part that project back of the plane of the what paper. So that also what we call perspective formula. And we have two main bonds. that represents atoms or group that project out of the plane of the paper or towards the viewer or back of the plane of the viewer away from what viewer. And we have these two main type of bond. Yeah, here the first bond here. This bond is called the ash wedge bond. Ash wedge bond. Right there. Ash wedge bond means that it's the bond where the atom is projecting away from the viewer that is extending back of the plane of the paper. Do you get? And we have what we call the solid wedge bond. Here we have solid wedge bond. Now this solid wedge bond represents the group or atom projecting towards the viewer. Do you get? So this group represents the atoms projecting out of the plane of viewer towards what the viewer. Do you understand? So this is what you want to understand here. So when drawing enantiomers, therefore you locate what the current center, then look at what that form that is attached to what that center. For example, here we have a carbon here. Then you know that there is having four different groups. Now, when you want to draw it here, these two bonds must be adjacent to each other. So one will be here, and one what will be what here. One will be what here. Do you see that? So you can do it like this. Remember, the carbon atom must have four different bonds, right? So here we can have main, two ordinary bonds here. Do that. But the key point here is that is these two things here. This is called the ash wedge bond. This is called solid wedge bond. This is that. So now, if for example here we are looking at what two bromo, two bromo what butane. Remember, two bromo butane is what CH3, C hydrogen, B and what CH2, CH2, right? I talk about this one, the methyl, the bromo, and what, and the hydrogen. This is that. So now the first one to do here is what draw it like this. You get that? They are the one that what that will decide to put the four groups at any point. So I can decide to put one here CH2, CH3. Now, what you want to understand is that anything or any group you put here, you should understand that it's pointing away from you. It's extending back on the plane of the paper. You get that? So it means that you can actually see it when you are viewing objects or structure in a three-dimensional form. Do you get that? There are some objects you can actually see clearly. Do you get that? Because it's at the back. This one represents is at the back. Do you get that? So this one is pointing away from you. Now, like I said to put one here, what you want to understand here, any group you put here represent that it's pointing towards you. Do you get that? It's projecting towards you, towards the word viewer. Do you get that? So you can see it clearly. Then here we have some just like in the plane. So here we have hydrogen and what? CH3. CH3. Do you see that? So now somebody will ask, Chris, can I put it in any order? You are the one to decide where to put this thing here because you are the one drawing what the enantiomers. So another person may draw it and say to put hydrogen here, try to put this one here. Do you get what change it? Do you get? So this is how to what draw enantiomers. Do you get? So this is what a carbon molecule that represent that is drawn using what the perspective formula. So the key note in perspective formula is what these two bond here, the ash wedge bond and the solid wedge bond. Do that. So when you draw the first enantiomers, now the next thing you want to do is to what draw the mirror image of this guy. Do that. So there's no way I can draw the mirror image of this guy. So let me see if I can draw the mirror image of this guy here. So if you draw the mirror image of this guy here, what do you see? You can see that here we have CH3, CH2. Here we have this one here, right? So here we have a carbon here. Here we have what? A hydrogen. Here we have this guy. Yes, sir. So here we have what? B what arrow. And here we have CH2. Yes. So these two are called enantiomers. So I have drawn this one here using the perspective what formula. This is what the perspective formula. So you have enantiomers. This is that. Now for me now after drawing so here you can now watch draw the R and S configuration, which I'm not going to do in this video. That going to be a complete different video where I'm going to teach you how to draw the arrow and S configuration. But in this video here, I'm going to teach you how to draw enantiomers. It's very, very important to know how to draw enantiomers. If this video has been helpful, if this video has been helpful to understand one or two things here, if this video is helpful and you are following, please just give it a like and say you are following and you're getting everything in this video. You get it goes a long way to tell me that you watching this video, you're actually following this video and you're getting a lot of value. And if you want more of this kind of video, leave like down, leave like the comment section that you want more of these videos that will help you in passing your exam. Now you can specify the topic that is giving you challenges, and I'll go ahead and will create video on that. Okay, now let's look at this one here, this example here. They say using the perspective formula to draw the enantiomers for 3-chloro-1 butene. So how do you do this here? It's very easy. First of all, let's draw the structure of this compound here. As an organic chemistry student, you must know how to draw organic structure using the IUPAC name. Do that. If you are still having issue with that, I've done a complete video on notation of organic compound. Do that. So you see the playlist at the description below. And I also done a complete video on how you can convert the IUPAC name to the structure. I also leave it at the comments. I will also leave it at the description below, or pin at the comment section. So if you want to check out that video, you can go ahead and check out that video here. 3-chloro-1 butene. So let's draw a structure first. Identify the numbers of chiral center. So here we have 1, 2, 3, 4, right? Now when we talk about 1 butene, that is one, the first chiral atom is a double bond here. So we go 1, 2, 3, 4. So 1, 2, 3, 4, right? At number 3, I have a chloro. Here we have chloro. So here we have 2 hydrogen. 2 hydrogen. 1 hydrogen here. Here we have 1 hydrogen. Here we have 3 hydrogen. So when you look at it very well, here we have CH2 double bond CH. Here we have this one here, chlorine, hydrogen, and CH3. So this one is the chiral carbon here. This is that. For example, 1, 2, 3, 4. Do you get that? So before you can start drawing enantiomers, therefore you must identify the numbers of chiral center here. Do you get that? So, and I've done a complete video like what I told you before on how to identify the numbers of chiral center and calculate the numbers of stereoisomers. So you can check out that video out. So now let's start drawing the enantiomers. First of all, let's draw the first enantiomers. Do you get that? Because we're going to have only two stereo isomers, 2 stereo isomers. So then remember when you are drawing enantiomers, first of all, a carbon that is having this bond here, then what? Remember I told that they must go adjacent to each other. This is called the hash wedge bond. This was solid wedge bond, right? They now have 2 plain bond here. So you are the one that will decide to put this in any order. Do you get that? So I can decide to put hydrogen here. Do you get that? I can decide to put CH2 here. I can decide to put chlorine here. I can decide to put CH2. I can decide to put CH2 double bond CH here. Just that. So these are the 4 group that is attached to the chiral center. So the next thing you want to do here is draw the mirror image of this guy. So how do you draw the mirror image of this guy? It's very easy. Draw the draw as if. Now imagine that there's a mirror here. This is that. So the mirror here we have this one here. Bring it to carbon. This is that. Then you have this one. This is that. And here we have this guy, and here we have this one. Now this one is hydrogen. Then here we have CH3. This is that. And here we have CH2. CH. Here we have CH double CH2. Right? And here we have Cl. Just see that. So we have draw enantiomers. So this video here, I just want to focus on a chiral molecule that has only 1 chiral center. So when the chiral molecule have only one chiral center, it can have what two stereoisomers. You know what the chiral molecule means what mirror image. Two of them are called enantiomers. They are called what enantiomers. Very important. So this is how to what use what the perspective formula to draw. This is how to what use the perspective formula to draw enantiomers. Do you see that? So remember I told you that there are two main formula, right? The perspective formula and the what Newman projection formula. This is how to what draw enantiomer using the perspective formula. So if you don't understand how to draw enantiomers using the perspective formula, you can leave it at the comment section that you now fully understood how to draw enantiomers using what the perspective formula. However, we have not done Newman projection formula. So let's look at what Newman projection formula. We talk about the Newman projection formula. Newman projection formula. Again, this one is a little bit more easier than the perspective formula. Now, in the Newman projection formula is a shortcut in drawing chiral molecule in three-dimensional form. Do you get that? It only uses vertical and horizontal line. It only uses vertical and horizontal line. Most of the time, you use what Newman projection formula. Now, when I see here, the point of intersection is what is the chiral center. Chiral what center is what chiral what center, or the what chiral carbon or stereo center. Do you understand? So this one means that is having 1, 2, 3, 4. So, but what you want to understand here is that we have to call vertical bonds, vertical bond. Okay. So this is called the vertical bonds. Okay, vertical bonds. Now, the vertical bond is the bond that is pointing away from you. Do you get? Now, when we did the perspective formula, I told you that there's a bond that is pointing away from you, right? Which is called the hash wedge bond. Do you understand? Now, in the what Newman projection formula, the vertical bond is the bond pointing away from you that extend back the plane of the paper. Do you get? So any object that is that vertical bond is actually what pointing away from you, that is extending to the back of the what plane of the paper. This is what you really want to understand. There is how we call horizontal bond. Horizontal. Now we also have call the horizontal bond. Horizontal bond. Right there. Now the horizontal bond is bond that is what we have call the horizontal bonds. Horizontal what bond. Now this horizontal bond is the bond that points towards you. Right there, that points what towards you. Do that. So yeah, you can see that this horizontal bond is just like what the hash wedge bond, and this vertical bond is not about the hash wedge bond. Why this horizontal bond is not about solid what wedge bonds. Solid what wedge bond. So this vertical bond is what bond pointing away from you that extends back the plane of paper. While this horizontal bond is one that pointing towards you. So this is what you really want to put in mind. Do you get that? So if for example, here we have CH2 here, here we have H, here we have what B what arrow, we have CH2. Look at this stuff here. Now this one is a chiral what molecule, right? A chiral molecule because it contains what chiral carbon. So if you want to use the Newman projection formula, it's very easy. Now how many chiral center do you have here? We only have one chiral center. So which one here? Now here we have hydrogen, the what the ethyl, the bromo, and the what the methyl. This is that. So now you are the one that what decide to put it in any order I want to put it here. So you can decide to put hydrogen here. Here I want CH2, CH3. Here I want B what and here I want CH2. This is that. Whenever you decide to what draw anyone, whenever you decide to put it here, here. You can what you are the one that will decide where to place those what groups or what atoms. Now, after drawing this one here, understand that this one here is the chiral center. So in the numerical projection formula, we don't actually show the chiral center. It's only the word intercept. So when I see an intercept, you know that what is the chiral center. The next year you want to what? Draw the mirror image. And to draw the mirror image, you only need what to put mirror here and draw it CH3, CH2, here we have CH3, right? Here we have what B what R, here we have what hydrogen. So they're called enantiomers. Remember that a kind molecule and this mirror image are called enantiomers. So you're looking at what enantiomers here. Just so this is the easiest way to what use the what Newman projection formula to draw enantiomers. So I believe this video is helpful. You can now use what the perspective formula and the Newman projection formula to draw enantiomers. So in our next video, we are going to look at what in our next video we are going to look at the R and S configuration. So you will don't want to miss out. If you have subscribed to the channel, please hit that subscribe button, turn the notification bell so that when I upload a new video, you'll be notified that a new video will be uploaded. Now, the purpose of this channel is to what help you pass your chemistry in flying colors. Drop your question in the comment section. Any video you want to do, any video topic chemistry you want to do for you. That is giving challenges. You can also drop it in the comment section. So you can go ahead and watch the first video about optical isomerism, how to identify the chiral center and numbers of stereoisomers. Or if you are still having issues with inductive effects, you can check out this video too. If you are still having issues with naming organic compound, I will leave it at the description. Do that. Thanks for watching. See you in the next video.